lovely data and a beautifully presented talk there. And you know, extremely important set of ideas that you're working on. I like it a lot. Children, I guess I have two questions. The more metaphysical one, which maybe it's hard to get into, but you know, there's an assumption here that there is such a thing as causality, that one can say in a given situation what has caused something and what has not, and that might be a little more problematic than you're treating it as, but I think that's a messy and complex thing that maybe isn't amenable to a quick discussion. The thing that's more amenable to a quick consideration is the fact that children learn games and they learn rituals. And in games and rituals there are things that you might call arbitrary. So when you're playing hopscotch, which I've never played, but I believe that you can't just reach down and get the jacks, or when you're playing jacks, there are certain things you have to do first.
Right.
And you just have to do them. I mean, otherwise you haven't played the game or you've cheated or whatever, it doesn't count as a turn. And they're arbitrary, and they interfere with getting it done quickly and so forth, and you're trying to do it quickly, but, you know, you're not allowed to do them. And that's true of every game, that, you know, if you're playing marbles, you can't just go up there and knock the marble over, you have to stay behind the line. And there are all these arbitrary rules that kids learn, and they wouldn't learn if they didn't observe and imitate and figure out that these constraints are part of the game. And the same thing is true of rituals, where, you know, even the anthropological observer can't always understand what, you know, and people can't explain why you have to do this and that, you just have to do it. Now, I'm not putting aside the question of sort of, is it adaptive to play games and perform rituals? Children have to do those things if they're going to function in a particular culture. And to do that, they have to imitate pretty much the intentional action of the observers. Now, they do have to distinguish between the guy blowing his nose, that's not part of the ritual maybe, he trips, that's not part of the ritual. So they do have to distinguish between intentional and non-intentional acts in games and rituals. But they have to do just what you're calling overimitation here.
Well, yeah, I think I mean, we definitely take that idea seriously. That's one of the core alternative that we try to address in a lot of these studies. I think, you know, the answer that we have for that is pretty much the two experiments that we've tried to do as covertly as possible. The one that I showed you where Felix steals the prize. There's a second one it's not as fun to present because it's much more subdued, but for that reason it might be kind of more naturalistic, is one in which as the kid's literally leaving the room, the experimenter is suddenly like in a tizzy because he remembers that another child is coming in like in 2 minutes to play the game. And he's racing around and sort of enlists the child to say, could you just go and check? My assistant sometimes forgets. Can you go check and make sure that the turtles are all back in the objects? So then the child will go in another room and like open up each one in sequence and make sure there's a turtle in there. And sure enough, they still do the overimitation. So it's not a perfect answer, but I think that the reason we wanted to do those experiments was to at least begin addressing this very point that you're making. And over, you know, in the future, the more naturalistic we can make these manipulations, and the more they blend in, the better.
You do tell children it's a game, is that right?
We tell them with the monkey game, that's the one that we frame as the racing game as a game.
So I wonder if a control in which it couldn't possibly be a game, in which, I can't think of the experiment right now, but in which there's no human agent performing the actions or something like that. Somehow you frame it so it doesn't look like a game, it doesn't look like a ritual. You'd have to think about what that would be. My guess is that these things go away.
Well, that's a good question. We haven't done that study. I think, I mean, my prediction would be that you might be surprised because it's surprised us all along. But I definitely agree that, you know, the question that you're asking is kind of one of the big hills that we need to get over as we add to this body of work, and it'll be an interesting one to see if we can tease apart more thoroughly than we've done. Yeah.
You know, in the example where you showed all 3 trials, in the second trial, the boy omitted one of the irrelevant actions.
Yep.
So in data, are you coding for any unnecessary action? Is that what the bar represents?
The
Because
bar,
in other words,
yeah.
were you sensitive to them dropping one but not all of the unnecessary items?
the bar represents the more overt case. So the tapping that runs throughout these experiments, we included that as a nod to stimulus enhancement and the idea that the experimenter is at least trying to sort of draw equivalent attention to both parts of the object, even though the way that you actuate the mechanisms differs between children. What we found is that kids will imitate those sporadically. What we code as overimitation is actually making the whole mechanism go. So that's the answer to the coding question. With regard to like what the pattern is, what we find is a really quite interesting that the level of granularity at which kids encode these actions seems to correspond to state changes in the object. So things that don't change its state, like tapping on it, are much more ephemeral. And some kids will copy them, some will sort of misplace them, as you saw that kid like tapping the wrong thing. They're much less attuned to it. Really the bedrock of what they seem to absorb and overimitate are things that change state in the object. And this is maybe not quite what you were asking, but related note. We did a bunch of coding to look at changes that kids made. And we found that, which I really like, the kids are very willing to make improvements to efficiency. So in the case where the adult sort of very effortfully like wiggles the bolt out by pushing it, kids are happy to like pull the bolt out. So that it's not that they're rote copying even when they overimitate. If the adult did it in a kind of backwards way, the kid's happy to improve. But they're very concerned with maintaining the state of the sequence of state changes that takes place. Yeah.
Following up sort of on that, so some of the kids only, maybe 1 in 5 didn't overimitate. Were they consistent? Was it the same 1 in 5 who, like, if they figured out on the first one to not overimitate, would they do it again? Because the percentages were about the same.
On the monkey, yeah, on the racing game, it, I think universally, there was never a case of a kid getting it right, i.e. not overimitating and then going backwards. It was just a question of like if and when they would drop. So there seems to be kind of a reverse ratcheting effect. Whereas, you know, if people sometimes ask, well, what if they watched an adult do it in a complicated way and then they watched an adult do it efficiently? And I think the clear prediction is that they go with like the floor of what it is that they've seen that works. So once they know that the simpler action works, they don't go backwards. But a lot of them never kind of fall off that ledge to get to the more efficient way of doing it.
And if you don't mind, how do they, do you ever ask them how they justify cutting a corner in some sense after the experiment? So some of the kids who
No, that would have been really interesting. We didn't think to do that at the time, which is kind of too bad, because that would have been a quite interesting question to ask. I mean, my guess is that they, once they've sort of gotten over that hurdle, that they'll just say, well, you don't have to do it.
Right.
But it's maybe not as revealing as it could be about what they're thinking beforehand. No. Yeah.
I'm struck by the fact that when, in the first experiment we talked about, kids could readily identify the parts of the task that weren't necessary.
Mm-hmm.
But then when you have this automatic causal encoding account, that suggests that they're unable to do that.
Mm-hmm.
So I was just wondering if you want to comment.
Yeah, I do want to comment on that. What we think the difference is novelty. And that's why I sort of stress novelty throughout when I'm talking about the puzzle objects. Always characterize them as these are the novel ones versus the training objects, which are things like syrup pourers, flour jars, zipper pouches, things that are familiar. So and this kind of connects back to that sort of downward ratcheting idea. Our account, the way we explain this is that if it's something that the kid uses every day and is familiar with, they've, over the course of time, they've reached that floor causal complexity for that object, and they don't want to go backwards. If it's something that's new to them, then they're quite receptive, even when it should be visually counterindicated to what the adult's doing. Yeah. Yeah.
A quick point, very interesting.
Yes.
In the Felix examples, when you had the kid do it, at all points, if I saw the video correctly, you gave the kid the irrelevant object, and it was the very last thing you did before you asked the kid to go ahead and do it.
Mm-hmm.
So if the kid were not to do it, first of all, they'd have to take this extra step of getting rid of the thing that the experimenter had just given them within some sort of a frame of relevance. And the second thing it occurs to me is that what's going on in all of this is not simply making abstract inferences, but learning sequences of embodied behavior. And that in certain ways, when you're giving the stick, you're already activating that embodied action complex in a certain sense.
Yeah, I think, so a couple of things to say about that. One is that, it's a good point, first of all. And if we were designing these objects again, we might, I would at least think about designing them a little differently to get rid of the little wand for this one and this one. The other objects, though, don't have that problem, right? So most of them, it's direct. The other thing is with the monkey box and the puzzle box, when the adult does it at least, he uses, it has a little, it's hard to see, the black end of the wand is a little Velcro tip. So because the opening is too big for the adult's hands, he sort of uses that Velcro tip to take the turtle out. So it is something that's used in the tapping and the irrelevant part, but it's also something the adult uses for the functional part as well. So it's a good point that probably that was a bit of a design mistake, but we sort of shifted away from that in later objects. Yeah.
Just to follow up on Joan's question, I'm wondering if, so the setup was a little bit different for the times when you tapped on the container with the feather, right? Have you done anything where you actually had the task be the same, but in one instance the object that they had to manipulate was novel, and in one instance it wasn't novel, like comparing something of equal complexity to one of these to something that they would have been familiar with, like a jar?
We did it a little bit, and the feather jar is a good illustrator because it's the simplest, but there's a very conscious progression in the training objects where the first two, the irrelevant action is something like put on a wristband and then pour out the dinosaur, or tap the jar with the feather, things that are really kind of crazy, jingle the bell. In later ones, it's a manipulation on the object, like I squish the silly putty onto it in a particular place, or I like write, with a little marker on the side of the object. So we tried to edge in the training objects from maximally transparent to more and more like the training objects, but that would be a really interesting experiment to do. I'd have to think about how you would do that, but to try and equate the kinds of actions as much as possible.
And also, yeah, and I wonder, things are going to be, if you did something cross-cultural, different things are going to be novel in different cultural contexts, and so you give them, through the same task that you gave that jar and feather task to the people that I work with who've never seen a jar that opens like that, they wouldn't actually know how to open it. You would predict they would be more likely to tap it with the feather than American kids would, right? Because they don't necessarily know how to do it. But, so in these ones, did they get worse at being able to pick out the over-imitation?
No, the trend was one of age. So 3-year-olds tended to have more trouble than 4s and 5s. There wasn't any systematic pattern in terms of the complexity. It seemed to be much more an issue of the verbal nature of the task. That the 3-year-olds were just a little spacier on giving, understanding the questions. But again, so we did see that's the big divide in the training data, younger versus older. It kind of washes out in terms of overimitation because I know Whiten, for example, has argued for age differences, but we've never seen a single age effect in any of the data that we've collected.
But they're as likely when you manipulate the object to pick that out as they are when you tap it with the
Yeah. In general, with the training, it's sort of like they get it and they get almost all of them right, or they're really shaky and they get very few of them right. Yeah.
And on these examples, with familiarity, then you're saying that children had no difficulty recognizing what was the irrelevant action. But with the novel objects, then they are following the sequence of what they've seen taking place. If one were giving them more time to play with the novel objects, more instances where they're seeing that all they have to do to get the turtle out is a specific thing.
Yeah.
Would one find, what would one imagine would be sort of the learning process is going through? Because at the moment, they have the novel object, they see, I guess, the trainer do it once, and you can do it directly, then they're given the sequence and they follow that. But presumably, if they saw the trainer do it 2, 3, 4, 5 at some point, they would be understanding, like with these, that they don't have to go through that sequence? Is there, you know, some kind of a learning process at which one sort of drops off on the irrelevant? There's one sort of, as one learns, he gets experience with it, the irrelevant part
Yeah.
is less and less pronounced, or?
I think I might make a different prediction from you if I understand correctly what you're asking. I think if they watch the adult do it over and over again, I think you'd have to do it for a really long time before they would suddenly not overimitate. If they were left with it, so I say I send a kid home with a puzzle box, I think what we'd see is innovation through forgetfulness, where sooner or later the sequence would just get, they'd forget a step. It might get muddied, and that process of like the gradual degradation of the signal might over time lead them to the simplest
Yeah, so
theory.
but suppose you gave them the opportunity to try many times, a child many times, to
Yeah.
get the turtle out
Yeah.
directly,
Mhm.
before they're shown the adult doing it in a longer sequence.
Oh, so before they watch
So they
the
had time to
okay.
have experience with it. Presumably it would end up with a situation eventually like this, but if they've had enough experience with it, they would recognize all the other ones as irrelevant actions.
I
Sort of
Yeah.
learning, I'm just wondering if there's sort of a learning sequencing that might be taking place.
given how simple these puzzle objects are for kids, I bet if we took one of the kids from the baseline group who opened it independently and then put them into an overimitation study, I really don't think they'd do it. I think, maybe you might see a little bit at first due to the kind of like, well, this is a kind of weird social situation, but I think like in a Felix study, where there's a lot of pressure and incentive to do as efficiently as possible, I don't think it would hold up. So I think once they have established experientially how the object works, it would be very difficult to kind of push them back uphill. Yeah, did you have another question to follow up? Oh.
So, I wonder why you call it automatic causal encoding. See, so if you think about functionally how imitation should be designed to get information about technology, most of the technologies that most people in the world use, even in really simple societies, they have no understanding, or only partial understandings of how those things work. So people, use bows and arrows and kayaks and all kinds of things that they can't tell you why they're designing the way they are. They can't tell you why they aren't built in various alternative ways. So you're inferring that the kids are inferring a cause, or just that there must be some cause? Because I'm happy with the latter,
Yeah.
not so much the former. Because the one kid said it'll get stuck, right? If you don't, I forget exactly what he said. The one example you showed us, but I don't see why that's a necessary. In fact, I would predict that that's not a necessary part of this. That it's what, in order to make the imitation work, to allow you to acquire things that you couldn't understand, you have to be willing to copy things, and even though you don't understand them, otherwise people couldn't acquire technologies that individuals couldn't understand.
Just a footnote to that. I haven't done this systematically, but you can walk around Southern California and ask people about knocking on wood to prevent bad things from happening, or talk about getting cancer and knocking on wood. And a lot of people will say, yeah, well, sure, it doesn't hurt, right? And then if you ask them, how is that supposed to work exactly, right? What's the causal connection between those things? Even people who actually will do this systematically, so they clearly think there's some possibility that it's have no theory about what the connection is. Right?
Yeah, so I've done some work where I ask people why they build houses in a traditional society, why they build them. There's a particular stereotype beam in all the houses in this Fijian village. No one can tell me what happens if you leave that beam out. And it's quite a bit of effort to get the wood and carry it to the place, and all the houses all through the Pacific have it, so it must be good for something. But they don't know, and lots of stuff like that.
So I think, when an example you're giving of the knocking on wood stuff, this is actually kind of part of my intellectual lineage, I guess, in the sense that Frank Keil, in some of his classic work, back at Cornell, did studies and continuing at Yale with asking undergraduates about staplers. How does a stapler work? How does like a bicycle derailleur work? So even things that people do use every day, that there is, like, if you really thought about it, like a clear kind of mechanical sort of story to be told, people can't do. So we don't think it's the case that what they're extracting from this is like a fully formed, like, you know, force diagram of like how the thing works. And that's an important point because I think it's been misunderstood. There's a paper that just came out in Proceedings of the Royal Society by a guy in Oxford who did the stuff with crows. I'm blanking out on his name. Yes. He did some looking at this, and he doesn't agree with this. He basically, in the studies there, to condense it really quickly, there's a whole series of them, but one of his core manipulations was to ask kids, okay, well, why did you have to do that? And he concludes from the fact that they can't answer that question, that they must not think it's really necessary. Well, we really disagree with that, or at least I do. I think Frank does as well. I think, you know, for the simple reason that, well, adults can't do that. But we still say that, like, well, if I'm using a bicycle, well, bike derailleur isn't the best example because I don't know how one works, but like with the car example, you know, I feel like I understand my causal theory of how these parts of the engine are connected is now such that I believe that there's some causal principle that unites unscrewing the bolt on the left from uncapping the container on the right. And that's about as deep as my theory goes, but that's enough to like transmit it to others for it to be like functionally preserved over time, et cetera. So that's what we think the level of theory that they're taking out of this is not so much an abstract understanding of how the object works, so much as a kind of user's manual of, in order to make the object go, one must do these things. And that they think there's causal importance attached to each of those steps, that it's not a ritual, that they have to take place.
The last step is an infinite. I mean, it's really not necessary for any of the functional. I mean, that.
Which, the last step of the causal?
There must be a
system.
causal. I mean, so that your picture is people don't do things unless they have a causal understanding of the machinery, right? And so I think that's. I mean,
well, it's clearly not generally true, but what we're trying to argue through over the course of these studies with like the cost attached to it and the various kinds of negative incentive to get rid of the actions, that the only reason it makes sense for them to preserve them that vociferously when they're losing to Felix over and over doing something that they really want to win is because they must think that there's a causal importance there. That's our interpretation.
But you're confusing procedural knowledge with conceptual or semantic knowledge. I mean, that's the point of Keil's experiments, right, with the stapler and the bicycle. People can ride a bicycle without understanding how a gyroscope works, without understanding that when a spinning wheel is turned this way, it tips this way.
Mm-hmm.
You don't need the conceptual knowledge to ride a bike successfully. I mean, maybe if you're at the very high end, a little more conceptual knowledge might make a little bit of difference, but what I think Rob is saying, or at least my interpretation is, that procedural knowledge is completely, or can be, completely distinct from semantic conceptual knowledge, so that you can know how to do something in a very skilled way without having any idea about, you know, the physics of the bow or the physics of the bicycle or whatever.
Mm-hmm.
So, I mean, there's plenty of evidence from memory researchers showing that that these are dissociable, that procedural knowledge is completely connected to practice to a certain degree. It's quite dissociable from conceptual semantic knowledge. So I think maybe what you're showing here is that, you know, these kids learn procedural skills in a certain way, and there's an interesting issue of how they abstract from the behavior to produce their own behavior, how it's encoded and so forth and so on, which you're getting at in a very elegant way, I think. But to say that they then, that in order to do these actions and governing these actions and governing their choices, there's a semantic theory of causality behind it. That's what that's what I was raising in the first.
Yeah.
They don't have to have any theory of causality any more than the Azande person who punishes a witch has any theory of how the witch caused the granary to fall down.
Mm-hmm.
That's never discussed, and the witch never says, I can't cause granaries to fall down. There's no discussion in the accusation or the defense about whether there's a causal connection. It's just there's a notion of, you know, there's a set of procedures there without any theory of causality at all.
Mm-hmm. Mm-hmm.
So I wonder if that's what you have here. It's pure procedural knowledge.
Well, I think it's procedural in the sense that I was alluding to, that we don't think it connects to a kind of like Newtonian physics account of how the object works. I think where we differ is that my interpretation of studies in which we attach as much kind of negative counterweight to the irrelevant actions as we can, in like the racing study with Felix, almost as much as we can, like ethically with a 3-year-old, to really make this a charged situation. I think there we get into, well, what counts as evidence that you think you have to do something in a kind of causal sense, as opposed to that's just the way it's done, or a ritualistic sense. And what I want to argue is that, as far as we can tell with the data that we've put together, it seems to be that causal sense. That's what our case is. But
in the Super Bowl, nobody pulled out a gun and shot the defending lineman and then walked across the line with a thing. Causally, that works. I mean, it gets you to the football across the line. But it's basic to human activities that there are constraints, and it doesn't count if you do it the wrong way. So people aren't always thinking in this causal way. They have procedural knowledge. This is the way you play the game, and it only counts if you do it this way. So if they didn't do it that way, there would be, So first, I think procedural encoding is different from semantic encoding, and the idea of causality is this very abstruse and carefully developed idea in a certain particular cultural, philosophical, and scientific tradition, which you don't need to function in a way.
I think it's also a lovely set of experiments. Also very nice that you've explored various boundary conditions, so you get much more insight into what's going on. I had a thought also regarding the discussion that's now going on.
Yeah.
I was thinking whether one way, maybe one kind of experiment that maybe you've already done or you could do, would be something where you give the child a forced choice between two or a set of actions that the adult has gone through. And I think the procedural account would predict that the child would be equally likely to engage if you say to the child, you can only engage in one of those actions to try to obtain the turtle with a novel object. And then I think the procedural account should predict that equal weighting should be attached to each of those actions, because the child has just encoded a procedure, and now it's randomly selecting among the sequence that constitutes the procedure which action might be associated with getting a turtle, whereas a more of a causal model account should predict that the child, even though it thinks that both actions might be necessary to get the toy, it could still be the case that it has weighted one of those actions a little more heavily than the other. So you could see whether it would be the case that children would differentially choose particular actions if you give them a forced choice.
Yeah.
I don't know.
I think that would be really interesting. It seems to me that a place that might shed particular light is something we haven't touched on, but the developmental progression of this effect is a big kind of question. We don't see any age effect across 3 to 5. There's been at least one study from Whiten's lab where they show that adults do it. And I guess my response to the fact that adults do it is kind of like, well, of course adults do it. We can think of more examples of adults doing it than kids. My gut intuition, though, is that it's a very different process when you're talking about an adult, because now it's a deliberate sort of like hedging your bets or Pascal's wager sort of thing, as opposed to with kids where we think it's really just entrenched. This is the way that the thing works. So it would be, I think it'd be interesting in any respect to do that study, but it might be particularly cool to look at, as kids get older, do the irrelevant actions kind of weaken before the ones that are actually like visibly necessary to extract the turtle. So yeah, that would be a cool one to do. Yeah.
I wanted to come back to this ritual idea that you were talking about too. If it's a ritual, you have to sort of follow these rules, but a lot of that has to do with who's watching you.
Yeah.
So in most of the, I think all of the experiments you left
Oh, yeah.
as a child. So if you kept an adult in the room, the person who demonstrated it, would you get fewer kids sort of testing the more efficient solution? So if you had a sort of comparison where you left half the time, the other half you didn't.
I think you would definitely see more overimitation. I mean, for some of these, there's a ceiling effect. Even with the adult out of the room, we're at a little over 90%. So I do think that the reason that we have the adult leave the room is precisely to avoid that kind of issue that's been sort of plagued the interpretation of prior studies. But I think, yeah, so I agree with you. I think you would see more, but for different reasons. Whereas now, like, maybe pick one that didn't elicit strong overimitation, like the central one, I can't remember which one is, the cage, I think. If that goes up to 90% now, it's a hard question of like, well, is it that 50% of kids are doing it for a causal reason and 40% are doing it socially, or what? But I do think you would see it. You're sort of adding two effects together, and you would get a greater overall. Yeah.
So you have some data that may speak a little bit to this in the, when you have two heuristics that you mentioned, the connectedness heuristic and the intentionality heuristic, you have a situation where you pit them both against each other. So the guys, you are intentionally waving your wand in an unconnected fashion. And what is, I don't know exactly, did you only encode the overimitation in terms of swiping the rod, or did you actually code for this waving action when it was intentional and looking kind of ritualistic?
Yeah, no, that's a good question. We coded for the blasting the thing out of the holder, which I remember distinctly because there were some kids that really got into that part of like winding up to like whack this thing out of its holder. I think, as best I can remember, the waving was much like the tapping in that it became a much more individual thing about some kids preserve it and some don't. And that's, I think, a question we don't have a strong answer to, as well as that some kids remember better, so that some kids are more sensitive to the kind of stylistic nuance. We know kids will dismiss stylistic bits when it's convenient to do so, but yeah, so anyway, I don't have a great answer for that question because we didn't analyze it in detail, but it seemed to follow along the lines of the tapping, of being something that was not as robust as the physical transformation itself. Yeah.
If we accept that there's the automatic causal encoding going on, would you then predict that on a novel but similar object to the one they'd just seen your demonstration on, that if it had similar properties, they'd therefore say, oh, I probably have to use that same strategy of removing the bolt before I go for the toy? And would that lend weight to your causal theories?
Yes, I'm trying to remember, we had proposed at one point doing like a categorization study based on that. I can't remember, blanking out on the specifics. But yeah, I think that's something that we toyed with doing but shied away from just because of the complexity of all the construction involved. But I think that would be a really fascinating thing to do. We know that kids will categorize according to causal principles. This is the part of a little fuzzy. I wish I could remember the specific study, but well, there's blanking on the. I think it's somebody at Northwestern did a study in the 80s where you show kids a novel thing and say this is either a rabbit catcher or it's like a fertilizer dispenser, and sort of turning it upside down. The important difference between the two is that a part that's functionally necessary to be a rabbit catcher becomes kind of like a carrying handle for the fertilizer dispenser, so it's not functionally necessary anymore. And when kids are then asked to categorize similar objects, they weight the causally important ones more heavily. So that's the essence that I'm remembering. That's what we wanted to do, was to say, okay, if this is, you've seen the monkey box, and now we're going to show you some things that are different from a monkey box but similar, which one is still a monkey box? We would predict that the presence of this feature should be really important, even though, because they should categorize it as though it was causally meaningful. So I think that would be a very clever study to do, but we just didn't have time. That was so fun. Yeah.
I'm struck by the similarity between these observations and adventitial or superstitious conditioning. I'm remembering those videos of pigeons pecking the corner, even though the seed box is going to open every 15 seconds, regardless of what they do.
Yeah.
I'm aware there was much additional research after that by Ehrenstein and others, but I don't really know the details. But this seems similar, except that in the superstitious conditioning versions, the subject itself does the behavior, then is rewarded, and then repeats the same behavior, even though it has nothing to do with getting the reward. And then they do that over and over again. Have you thought about that comparison and what it might mean?
Well, with regard to the subject doing it themselves, we sort of anti-thought about it in the sense that we designed the objects for, from our perspective, this is like the perfect kind of object for us, because it's one that you don't, in operating independently, you don't stumble on that irrelevant mechanism and then perseverate. But it would be interesting to look at. I mean, I think the superstition and I've sort of put the ritual ideas into the same category. It becomes difficult to talk about because personally, I think what happens is that you get the same effect for different reasons. And so a lot of what we've tried to do is to tease apart the account that we want to tell from something that is more of a superstitious behavior, just perseverating on the first response. So I think they're like getting a little muddled. I think they're related in the sense that they can give rise to the same behavior. I think what we've tried to do with kids is to strip away alternatives other than the one that we're trying to demonstrate. So we haven't really looked at it, but certainly it's closely related to this kind of stuff.
Well, I wasn't bringing it up as a criticism.
Yeah.
I was just saying that non-human animals are built to repeat the things that led to reward.
Yeah.
And humans are built to mirror what appears to lead to a reward. So the two devices, the two mechanisms might be closely linked.
Yeah, that's a good point. Yeah.
So I've changed my mind in the last 20 minutes, which is longer than it usually takes me to change my mind. When you first presented the, evil Felix steals the bracelet, now we must be quiet, no adult present results, I thought, okay, that's quite compelling, right? The kid is really, understands that how to get the object with the operating the zipper, but it's still manipulating the bell and so on. But I'm increasingly persuaded by Alan's point. By the way, I'll cite his preface about all those nice things he said about your talk. I agree. And here's the kicker, right? Which is that in that experiment, it's still dealing with Felix. Okay? And I would be really surprised, maybe some of the 3-year-olds, but even that I would be really surprised, if any of these kids think that Felix is alive. Okay? They may be a little mystified as to exactly how it is that Felix is animate and all that. But they understand that this is a game, that's a puppet, right? It looks like toys that they play with. Somewhere, either there's a machine operating that or there's a hidden adult operating that, but this is a game, right? That's not a real orangutan.
No, I mean, I think this comes down to intuitions about kids, but I would disagree with that. I think with children at this age, there are the categories, animate, inanimate. I think the category that matters more is agent, non-agent. Felix is clearly an agent to these kids. Do they think he's alive? I don't know. I think they think he's intentional. They think that he has will and can act and can, independently pick things up and vocalize and react contingently. I mean, there was a wonderful study by, I can't blank on the name, a woman at Harvard who did this thing with a furry blob, just like an undifferentiated blob of fur. And if the thing had apparent eyes, like 2 little buttons, and would sort of, it could wiggle around and it could make little warbly sounds. If it did that contingently, then kids would follow its gaze. And we're talking infants, that if the thing's kind of shimmying, it makes noise when you make noise. If all of a sudden the little button eyes go over here, then kids would follow the gaze. So they're treating it as an agent. They extract the same, it triggers the same responses as an animate person.
I disagree entirely. I think that the power of eyes to elicit responses is a very low-level phenomenon.
Gaze following isn't low level. I mean, chimps will follow gaze to some extent, but
No, it is very low level in the sense that the eyes are a stimulus by themselves. You can present disembodied eyes that are not connected to any agent and still elicit responses from adults with those. I know, we've done the experiment. I think that kids think Felix is a toy, and he's a very fancy toy, right? But he looks just like the toys that they have in their preschool. He doesn't look like a real animal, right? And somehow they're in a game frame where they're playing with a toy. And that means, as Alan has suggested, that there are rules about how you play this game, right? I think there are experiments that you could do. I mean, it's really easy for us to sit on the sidelines and give this, right? But there are experiments that you could do that would provide more compelling evidence. So along the lines of somebody, I can't remember, maybe it was Will McCarthy who suggested it. We're sitting near each other, so cognitive conflation. I mean, one possibility would be give the kids the monkey box first. Let them explore it. Tell them there's a prize inside. See if you can figure out how to get the prize out. Okay? They get that out, right? And now that they know what the affordances of the object are, right, through experience, right, present the competitive context and the non-competitive context where they're just going against a clock or something like that. And there are no rules. There's nothing about, you know, this is a game, this isn't a game, right? And see whether you can get them to overimitate after having watched them go along, right? Once they know what the affordances of the object.
Well, they won't overimitate because they already have like the floor complexity. So now when they're watching the adult, they're saying, okay, now you're doing something that I know from my own experience isn't meaningful. So this is a stylistic point, which we know that they'll drop out from like the fine-grained analysis of the data that we have. So yeah, I mean, I think I would respectfully but strongly disagree with you on Felix point from doing these experiments with several hundred kids. They really think that Felix, they treat Felix as an agent. I don't think they think he is alive in the same sense that if I put a lizard on the floor, that's alive. But I think they have a category that's not one that we as adults recognize for something that is agentic and that they treat as having intentions and behaving accordingly. So yeah, I think I would just disagree with you on that point.
Okay, on that note, I think we're done.
Thank you.